Okay, so we are still in section 10.4. We have one more test to test for convergence of a series. So we need our series again for the ratio test to have positive terms. So the only one that works for negative terms is if we use the absolute value part. That theorem said we could absolute value it and still use it. But if we don't do that, our ratio test would work for positive terms only. So ratio test, we need positive.
April, I'm gonna pop to the office. Would you kind of keep an ear out, eye out on my kids?
Yeah.
It's the class.
That class?
The class.
The class.
We need positive terms and we need the limit as n approaches infinity of a sub n plus 1 over a sub n. So the next term over the term before the next term. I don't even know how to say that really. But n plus 1 is just after n, the term after n, to equal a number.
Your number's L.
Yep. L just stands for limit, equals some limit. All it's saying is we can't have this limit be infinity. If it equals infinity, it doesn't tell us anything. It has to equal a number. So if, and we have three possibilities, if that number, that limit, is less than 1, then the series converges. If that number is bigger than 1, the series diverges. And if that equals 1, we don't know anything. The test fails. Now our ratio test is kind of going to be our go-to test. It'll work in most situations. So we're going to like this a whole lot more than the direct comparison test, because the direct comparison test requires a little bit of fuzzy thinking of what's bigger, what's this limited by. This one's very straightforward. You plug in n plus 1, divide by n, see what you can do to simplify. I mean, the simplification is hard, but the concept of the ratio test is pretty straightforward. Did everyone have that ratio test down before I
No.
scroll all the way down? In fact, I'm going to go.
Sorry, just reading over them, they really are though.
Okay.
Right, when no one is looking.
Sex means what? What?
What? So I guess
Sophomores.
That doesn't even
Okay.
make sense.
We are ready for this example. So, first of all, we have to consider, does this have positive terms?
Yes.
Yes. We have positive terms only. Positive terms is a go. Positive terms, check. So, once we make sure, yes, there's positive terms, we can then plug in to our ratio test. So when I say a sub n plus 1, what am I going to do to find a sub n plus 1?
The series plus one.
The sequence, okay. But is it like that?
No.
What do I mean by a sub n plus 1?
And
Everywhere there's n, we plug in n plus 1. It's kind of like function notation. If I said f of n sub n plus 1, you would know exactly what that means. So everywhere we see n, we're going to plug in n plus 1.
So the Fn plus 1 is the same as An plus 1,
Yeah,
basically.
basically. The sub part is what you actually plug into the variable. So, according to the ratio test, I take the limit as n approaches infinity of a sub n plus 1 divided by a sub n, and it must be in that order. We can't flip it. When we did chapter 9, we had some tests where it didn't matter what order, it just mattered our conclusion when we were comparing rates of growth. I could put e to the x over x squared, or I could put x squared over e to the x. One would give me infinity, one would give me 0. And then we'd know from our conclusion. This time we have to put it in this order. But a lot of the time when we use this test, we already have a fraction. So when I do this, instead of writing a fraction over a fraction, I'm going to write a sub n plus 1 first. So here's my a sub n plus 1. And when I divide it by a sub n, I'm going to automatically flip it. Or if we need to, if automatically flipping it makes us forget that we're actually dividing, we can write the division first. Why I didn't put that in the exponent, I have no idea why. And then go through and flip it. But that way we don't have a giant function fraction over another function fraction. So it'll make us a little bit easier for us to simplify. So now the hard part on the ratio test is usually the simplifying. What looks like it would go together for us to simplify?
3n.
Okay, the 3n and the 3n plus 1, those are probably going to simplify somehow. So these two we've got to worry about. Factorials are probably also going to simplify. So really we're worrying about, and you don't have to write it out when you actually do a problem, but we're really worrying about how do I simplify 3 to the n plus 1 compared to 3 to the n? What do we do when we have exponents and we're using the same base, but we're dividing? Subtraction. If I had x to the 4th over x squared, you'd know, oh, I know that's x squared. It's the same thing. We're actually subtracting our exponents. And what's going to happen when we do that subtraction? Just 3 to the 1st, ends cancel. We still have the limit out front. 3 to the 1st. So now we have to worry about how do we cancel our factorials. We have n factorial over n plus 1 factorial. So we have to think about what does our factorial really mean. What do we do if I have 10 factorial? Blah, blah, blah. What if I have n plus 1? Let's concrete it again, have an actual number. What would n plus 1 be if we used 10? Is our factorial? 11 factorial. It's, I don't know why I went with factorial. 11 times 10 times 9. What's going to happen? Everything but the 11 canceled. So what's going to cancel on our factorial over here? What's going to be left?
N plus
n plus 1. We're going to leave n factorial. We can write n plus 1 factorial as n plus 1 times n factorial, because it's really n plus 1 times, and then we subtract 1. N plus 1 minus 1 is n times n minus 1 times n minus 2, so all the rest is just n factorial. So we're left with 1 over n plus 1. So we've got to get used to canceling these factorials.
So is that 3 to the first times?
Yep, 3 to the first times 1 over n plus 1. Now we can plug in infinity. What's going to happen when we plug in infinity? You're going to get 0. We have 3 over infinity plus 1. And again, we're really looking for a pattern. So what do we know when we get our final answer? We have to go back to what are our possible conclusions from this. So going back all the way up to the ratio test, what does it fit under? Category 1. Category 1 says if our limit is less than 1, we converge. So, as Evelyn said, this function converges. So because 0 was less than 1, then (3 to the n over n factorial converges.
In the AP test, would we have to put something like 0 is less than 1?
I would say yes. I would actually even get more specific. I wouldn't just write 0 less than 1. I would write because the limit was less than 1 according to the ratio test. The sum of 3 to the n over n factorial converges. So again, you're going to have a lot of time on your assignment today. And I'm actually going to make you guys all sit by each other so that you can all work together.
Wait, now for a second.
Got a lot of time to work on this.
These tests, when you're just working on them randomly, are very confusing. So I want to make sure we have plenty of time for you to ask me questions, for you guys to talk to each other about the questions. Because when you're just randomly saying, well, what test do I start with? We need to get that practice. We just need practice now. So again, we're on page 515.
Chemistry's every day.
We've already done some of these problems, but I'm going to make you do them again.
No, 14. Why did I say 12? What?
Still recording.
Way to go, Emma.
That was all Evelyn.